A very nice welcome to the Wandering Chemistry. These all videos are promoted by fashionable film city Bollywood movie developers. Now today we will talk about the hydrogen bond. In order to understand the concept of hydrogen bond, let us consider a molecule, say capital H, in which H atom is linked with a strongly electronegative atom A. A may be F, O or N by a normal covalent bond. The electron pair being shared between H and the strongly electronegative atom A will evidently lie far away from H atom, and thus partial positive and negative charges will be developed on H and A atoms respectively. Consequently, HF molecule will behave as a dipole represented by H sup delta plus single line H A sup delta minus, with A as its negative and H as its positive end. If another molecule H single line V, which also forms a dipole H sup delta plus single line B sup delta minus, B is a strongly electronegative atoms like F, O or N, is bound near H single line A dipole. These two dipoles will be linked together by a special type of bond which is called hydrogen bond and is represented by dotted lines. Thus the existence of hydrogen bond between A single line H and B single line H molecule can be written as A sup delta minus single line H sup delta plus B sup delta minus single line H sup delta plus. H atom acts as a bridge between the electronegative atoms and B. Thus, hydrogen bond can be defined as follows. The attractive force that binds a hydrogen atom, which is already attached with a strongly electronegative atoms of molecule, with another electronegative atom of some other molecule, is known as hydrogen bond. Thus atoms A and B may be the same or different, that is the molecules AH and BH may be the same or different. We see the definition again. The attractive forces that binds a hydrogen atom which is already attached with a strongly electronegative atoms of molecule. For example, here it is HM molecule with another electronegative atom of some other molecule. Here it is BH molecule, is known as hydrogen bond. The atoms A and B may be same or different, that is the molecules AH and BH may be the same or different. Types of hydrogen bonding. Hydrogen bonds have been classified into two groups. First, intermolecular H bonding, also called associations. The hydrogen bond occurring between two or more similar or different molecules is called intermolecular hydrogen bonding. Example, in H sub 2O, NH sub 3 and HF molecules. When a number of HF molecules are brought together, the positive end of one dipole H sup delta plus single line F sup delta minus attract the negative end of the other similar dipoles H sup delta plus single line F sup delta minus, and these molecules are associated together to form a cluster of open braces HF close braces sub N. The formation of the associated molecules of the hydrides of N and O oxygen. Example, open braces NH sub 3 close braces sub N and open braces H sub 2O close braces N is due to the existence of their intermolecular hydrogen bonding in NH sub 3 and H sub 2O molecules. Their formation. Now, second types of hydrogen bonding is intramolecular H bonding, also called chelation. Hydrogen bonding occurring within a single molecule is called intramolecular H bonding. In intramolecular H bonding, the H atom is bonded to two atoms of the same molecules. This type of H bonding may be lead to the linkage of two groups to form a ring structure. For example, in orthonitrophenol and in orthohydroxybenzoaldehyde and salicylic acids are the examples of intramolecular H bonding. Now, properties of hydrogen bond. First, H bond is a bond of hydrogen between two electronegative atoms only. It never involves between more than two atoms, excluding H atoms. Second, bond energy of a H bond, that is hydrogen bond, is the range of 3 to 10 kilocalorie per mole, while that of normal covalent bond is in the range of 50 to 100 kilocalorie per mole. Thus, a H bond, that is H B bond, is much weaker than a covalent bond A arrow H. Third, the formation of a H bond does not involve any sharing of electron pairs. It is therefore quite different from a covalent bond. Fourth, compounds containing hydrogen bond have high melting and boiling point. They are generally soluble in water. So we see some compounds which have H bond, like H2O liquid, it has high boiling point. Similarly, HF liquid with high boiling point, NH sub 3 gaseous, it has high boiling points. Again, CH sub 3 OH liquid, it has high boiling point, and all these H bonding molecules are soluble in water. And some compounds which have no hydrogen bonding, like H sub 2S gaseous, low boiling point, HI gaseous, low boiling point, pH sub 3 gaseous, low boiling point, CH sub 4 gaseous, low boiling point, pH sub 3 and CH sub 4 etc are insoluble in water because it has no H bonding. Now we see the condition of resonance. First, the relative position of all atoms in each of the resonance form must be same. The arrangement of electrons may differ. Second, the number of unpaired and paired electrons in each of the resonance forms must be the same so that a continuous change from one type of bond to another type may occur. Third, contributing structure should be of equal energy. Fourth, like charge should not reside on atom close together in a contributing form, but unlike charge should not be greatly separated.